Welcome to Aptitude for Placements, and my name is Ranjit. I have conducted this aptitude training program at various engineering colleges all over India, and every year thousands of students get placed by attending this aptitude training program. Here you will find all the questions that are commonly encountered in most of the aptitude tests. These are the questions that keep on repeating in many of these tests. So just familiarize yourself with all these questions and you will have a clear advantage when you attempt your actual placement test. Let's start. The distance between two cities A and B is 150 kilometers. So I'll just mark it here. So you have two cities A and B, and the distance between them is 150 kilometers. A car starts from A and moves towards B at 50 kilometers per hour. So there's a car here and it is moving towards this point and its speed is 50 kilometers per hour. After 30 minutes, a bike starts from B and moves towards A at 12.5 kilometers per hour. So there's a bike here. After half an hour, the bike starts in this direction and its speed is 12.5 kilometers per hour. At the instant at which they meet, what is the distance traveled by the car? Now here it is mentioned after 30 minutes a bike starts. So for the first 30 minutes, only the car is moving. So we'll just calculate the distance traveled by the car in the first 30 minutes. Now the basic formula is distance by speed gives you time. This can also be written as distance is equal to speed into time. So using this formula, we'll just calculate the distance moved by the car in the first 30 minutes. Speed of the car is 50 into time. Time is 30 minutes. This is 50 kilometers per hour. So this 30 minutes we'll have to convert into hours. To convert minutes into hours, you have to divide by 60. 30 divides 2 times. So 50 into half. You will get it as 25 kilometers. So in 30 minutes or in half an hour, the car will initially do 25 kilometers. Initially the car will do 25 kilometers. So if this is 25, then the remaining distance will be 125 because it should add up to 150. This is 25, this should be 125. Now the car is here and they are moving towards each other. The car and the bike are moving towards each other. So first we'll just find out the time required for them to meet. Distance by speed gives you time. Now to meet, the distance that they have to cover is 125 kilometers. Distance between them is 125 kilometers. You can see that they are moving towards each other. So they are getting closer by 50 plus 12.5. So relative velocity is 50 plus 12.5. You will get it as 62.5. So we'll calculate the time required, that is 125 by 62.5. That you will get it as 2 hours. So that is the time required for them to meet. So now the time required for the car to meet the bike is 2 hours. Now we'll calculate the total distance covered by the car. Initially the car does 25 kilometers and then in 2 hours the car will meet the bike. 2 hours and every hour the car will do 50 kilometers. So 25 plus 2 into 50 is 100. So 25 plus 100 gives you 125 kilometers. So the total distance moved by the car is 125 kilometers. That is option C. The distance between two cities A and B is 300 kilometers. So we'll just mark it here. So two cities A and B, and the distance between them is 300 kilometers. A car starts from A and moves towards B at 40 kilometers per hour. So there's a car here and it is moving towards B and its speed is 40 kilometers per hour. 45 minutes later, a bike starts from point B and moves towards A at 50 kilometers per hour. So there's a bike here and it moves towards this point A, and its speed is 50 kilometers per hour. What is the distance from their meeting point to the midpoint of the two cities? Now here it is mentioned 45 minutes later a bike starts, which means that for the first 45 minutes only the car is moving. So first we'll calculate the distance traveled by the car in the first 45 minutes. Now the basic formula is distance by speed gives you time. This formula can be written as distance is equal to speed into time. So we'll just substitute into this formula and calculate the distance covered by the car in the first 45 minutes. In the first 45 minutes only the car is moving. Speed of the car is 40 kilometers per hour into 45 minutes. Now this is in kilometers per hour. So this 45 minutes will convert into hours. To convert minutes into hours, you have to divide by 60. We'll just cancel the common terms. 15 divides 3 times, 15 divides 4 times. 4 divides 10 times, so 10 into 3 gives you 30. So 30 kilometers. That is the distance covered by the car in the first 45 minutes. So initially the car in 45 minutes the car will do 30 kilometers. So remaining distance has to be 270 because it has to add up to 300. 30 plus 270 is 300, so remaining distance is 270. Now the distance between the car and the bike is 270 and they are moving towards each other. So first of all let us calculate the time required for them to meet. Distance by speed gives you time. Distance between them is 270 kilometers and they are getting closer. And they are getting closer by 40 plus 50 kilometers per hour. That is time required is 270, distance is 270. By speed or relative velocity they are getting closer by 40 plus 50, 90 kilometers per hour. I'll cancel the zeros. So 27 by 9 you will get it as 3 hours. So in 3 hours from this point onwards, in 3 hours they will meet. So first of all let us calculate the total distance traveled by the car. Initially the car travels 30 kilometers and every hour the car moves 40 kilometers, like that for 3 hours. That is 3 hours, every hour 40. So that you will get it as 30 plus 3 into 40 gives you 120. So that will be 150 kilometers. So when they meet, the car would have traveled 150 kilometers. And you can see that that is actually the midpoint. Now what is the distance from the meeting point to the midpoint of the two cities? Now distance between the two cities is 300 kilometers. So their midpoint will be 150 kilometers. That is the midpoint. And the car has also traveled 150 kilometers. So this is the midpoint at a distance of 150 kilometers from A as well as B. And the car has also traveled 150 kilometers. So the midpoint and the meeting point, they are one and the same. So what is the distance from the meeting point to the midpoint? They are both the same point. So distance between them will be 0 kilometers, option D. A and B are running a race. A speed is 15 kilometers per hour and B speed is 20 kilometers per hour. So we'll just write down that data here. A speed is 15 kilometers per hour and B speed is 20 kilometers per hour. So you can see that A is slower. So A will take a longer time. Lesser the speed, greater will be the time required. When the race was completed, one person took 16 minutes more than the other. So what is the race distance? So obviously the person who took 16 minutes more should be A. Now the basic formula is distance by speed gives you time. So we'll just substitute into this formula. Now what is the race distance? So D is what we need to find out. So the equation is like this. Race distance is D divided by A speed is 15. So this is the time required for A minus time required for B. Distance is D by B speed is 20 and that is equal to 16 minutes. Now these speeds are given in kilometers per hour, 15 kilometers per hour, 20 kilometers per hour, like that. So 16 minutes we'll have to convert into hours. To convert minutes into hours, you have to divide by 60. So this is the equation. We just need to solve and calculate the value of d. Now to solve it, I'll multiply throughout by 60. 60 is the LCM of 15, 20 and 60. So if you multiply by 60, all the denominators will cancel out. So 60 into d by 15, 60 into d by 20, 16 into 16 by 60. So here 15 divides 4 times, so that will be 4d. Here 20 divides 3 times, that is 3d. 60 and 16 cancels out, you will get it as 16. So 4d minus 3d, that is d is 16 kilometers. So what is the race distance? Race distance is d, that is 16 kilometers, option A. A and B are running a race. A speed is 9 kilometers per hour and B speed is 10 kilometers per hour. So I'll just mark it here. A speed is 9 kilometers per hour and B speed is 10 kilometers per hour. When the race was completed, one person took 32 minutes more than the other. What is the race distance in kilometers? So you can see that A is actually slower. A speed is only 9 kilometers per hour. So A will take more time. So one person took 32 minutes more. So that person has to be A. So now you have the basic formula, that is distance by speed gives you time. So we'll just substitute into the formula. Now first we'll calculate the time required for A to complete the race. That is distance, we'll take it as d by A speed is 9. So this is the time required for A, and lesser the speed, greater will be the time required. And next we'll calculate the time required for B. Same distance d by B speed is 10. So time required for A, time required for B, and their difference is 32 minutes. Now this is 9 kilometers per hour, 10 kilometers per hour and so on. So this 32 also will convert into hours. That is, to convert minutes into hours, you have to divide by 60. 32 by 60 is same as 16 by 30. LCM of 9, 10 and 30 is 90. So we'll multiply throughout by 90. So all the denominators will go off. Then we can easily solve this equation and calculate d. So I'll multiply throughout by 90. Here 9 divides 10 times. So 10d. Here 0 and 0 cancels out. 9 into d gives you 9d. 30 divides 3 times. 16 into 3 is 48. So 10d minus 9d, d is equal to 48 kilometers. So what is the race distance? That is d. d is equal to 48 kilometers, option C. A person walks from point A to point B and then returns to point B by running at a faster pace. So initially he goes from A to B by walking. So we will assume that the time for walking is W. And then he returns to point B by running. And the time required for running, I'll just take it as R. The total time taken for the to and fro journey was 8 hours. So total time is 8 hours. He could have reduced the total time by 2 hours if he had run both ways. So if he is running both ways, from A to B he'll take R hours, and to return again he'll require R hours, and he could have saved 2 hours. So he'll take 2 hours less, he will actually take only 6 hours. What would have been the total time in hours if he had walked both ways? Now from this you will get R plus R is equal to 6, or 2R is equal to 6, or R is equal to 3. So we'll just substitute R is equal to 3 here. So W plus R is equal to 8 and R is 3. So W plus 3 is equal to 8, or W you will get it as 5. 8 minus 3 is 5. Question is, what would have been the total time in hours if he had walked both ways? So one way it will be W, and then return also it will be W. So that, and W is 5. So 5 plus 5, total time required will be 10 hours. So option B, 10. Let me briefly explain how to prepare for your aptitude test. First of all, you need to familiarize yourself with all the questions that have been worked out here. These are the questions that keep on repeating in many of the aptitude tests. After that, you need to attempt practice tests. According to me, you need to attempt at least 10 practice tests before your actual placement test. Here, I will be giving you 10 practice tests, and these practice tests will be ideal for you to improve your test scores. The 10 practice tests are available at a cost of only Rs 200. So all that you need to do is make a payment of Rs 200 either through Google Pay or through PhonePe or through Paytm, and you will receive the 10 practice tests. The details of the payment comes next.